Okay, so with our mole map, it's kind of a continuation of what we did in our last unit. If you haven't seen that, go back and check it out. But with our mole map, we know that we are working with units of particles, which is the sciencey word for things. So that could be referring to atoms, it could be talking about formula units, or it could be talking about molecules. Okay, all of those are in the same spot, I guess. And then you could convert those things using Avogadro's number, so 6.02 times 10 to the 23, into moles. And then when you're in moles, you could change moles into mass, which has units of grams, by using the molar mass. So this is what we were using in our last unit. Now, let's say this is of substance A. So this is particles of A, moles of A, grams of A, right? Now, let's say I have substance B. Does my mole map look any different? If you said no, then you would be correct. So over here, you're still going to have particles, right? Which also is atoms, formula units, blah, blah, blah. You can still use it to convert from 6.02 times 10 to the 23 into moles. And you can still use molar mass to convert into mass or grams. Okay, so no matter what substance you're in, whether or not you're in A or B, your mole map looks the same. It doesn't change. Now, the new thing that we learned about in the video before is we talked about how you can, stoichiometry is the relationship between elements in a balanced chemical equation. So if I have an equation that says A plus B produces C, and these A, little b, little c, those are my coefficients. Well, now I have a balanced chemical equation that relates substance A to substance B. And so what that means is that we have a relationship. We have a third arrow that is going to connect these two things, and it's through our mole ratio, which we learned how to get in our last video. So our mole ratio, or aka coefficients, right? So that would be these in this fake equation that we wrote. So we can now go start anywhere on the map, and we can go to any other place. So let's say I have grams of B, right? And I want to be able to get the particles of A, right? So I have to change from B to A, and I also have to change from grams to particles. Well, in order to do that, I just follow my road. So we pretend it's like a bus stop. I start at grams, I go on molar mass road, I pause on the bus, right? Because when you're on the bus, you might make a lot of stops, even if that's not the one that you're ending up at. So moles to B, and then in order to get particles of A, I'm going to go up this road here to moles of A, and then across Avogadro's road to particles, right? So we can see that's a 1, 2, 3 step problem. And so we can see how this problem is formed. So we're going to use this mole map in order to do our stoichiometry problems. Now, remember, if you're in CP, I will give you the mole map. If you're in honors, you kind of have to know it yourself. So I recommend making sure you practice writing it. So let's go to the next page and look at some practice. With our mole to mole problems, okay? So that means converting from moles of one thing to moles of the other. We give you a little hint. We say to remember to change the compound, the units have to be in moles. So that's saying in order to go from A to B, you have to be in the mole section. That's the only place that they're connected. And so it says, in the following reaction, if 2 moles of potassium chlorate is decomposed, how many moles of oxygen are produced? So remember, the first thing you want to find is your given. So in this case, we are given 2 moles of potassium chlorate. Now, you might be saying, Miss Nichols, I've completely forgotten how to go from name to the formula, even though we've been practicing it for months. But since I give you a balanced chemical equation, you should be able to know that it has to be one of those 3. Okay, and so because chlorate ends in ATE, that means it's going to be potassium, chlorine, and it's going to have some oxygen in it. So that means I have 2 moles of KClO3. And our given, this is our given. And my goal, or where I want to go, is they want to know how many moles of oxygen. So that's my goal. So what we do is we look at where we're at on our mole map and where we are going, because the way we set up our T-chart, okay, which is exactly like in our last unit, is wherever we start, those units go on the bottom and our next stop goes on top. Now sometimes that next stop is also our last stop, but it's not always, and we'll work on knowing how to determine if it is. So first we're going to need to look back up at our mole map. So flip your page over to your mole map. Now that we're here, what I like to say is that A is my given and B is where I'm going. So I'm actually going to write that over here. So A is your given, B is your goal, so where you're going. So that means we know our given was moles of A, and we want to get to moles of B. So that means in order to do that, we're going to have to travel along mole ratio road, and it will be 1 step in order to get there. So when we are looking at our problems, we are starting at moles of A or moles of KClO3. So we can again say that this is A and oxygen is B. So we're starting there, and our next stop was we crossed over mole ratio road to moles of B or moles of oxygen. And we see in our problem that oxygen is not oxygen by itself, it's moles of O2 because it's diatomic. And the road that we used to go from moles of A, or moles of potassium chlorate, to moles of B, which is moles of oxygen, was mole ratio. So that means we need our coefficients. So the coefficient in front of potassium chlorate is a 2, and the coefficient in front of oxygen is a 3. And so I'm going to highlight those in green just so that we're reminded of where these numbers come from when we're looking back on our notes. You could also draw arrows from the coefficients to inside your T-chart. So if you're looking back, you have that in your notes and you don't forget. And so the next part is to check what you have here in the top right. So if those units match your goal, then you can stop. If it does not match, then you need to create a second step and keep going. So in this case, moles of oxygen matches our goal. So that means I can stop and put this in my calculator. So the same way as before, you always start with your given, so 2, and then because the 3 is on the top, we multiply by 3, and the next 2 is on the bottom, so we divide by 2, and so that will give us 3 moles of oxygen as our problem. So that is how you do a mole-to-mole problem, and check out the next video for how to do a mole to gram or gram to mole problem.